Sinusoidal oscillators. An oscillator is a circuit which produces periodic AC signals with the prescribed properties like waveform, frequency, and amplitude. In an amplifier, an AC input is amplified to an AC output with a DC controlled input. But in an oscillator, a DC power input is converted to AC output without having an AC input. Sinusoidal oscillators are oscillators which produce an output having sine waveform. They are called sinusoidal or harmonic oscillators. They can produce a frequency ranging from 20 Hz to 1 GHz. Non-sinusoidal oscillators produces square wave, rectangular or sawtooth waveforms. They are also known as relaxation oscillators. They can produce frequencies ranging from 0 Hz to 20 MHz. Now we are discussing only about sinusoidal oscillators. Tuned circuit oscillators. These oscillators use tuned circuit consisting of inductor and capacitor to generate high frequency signals. Therefore, they are known as high frequency or radio frequency oscillators. For example, Hartley, Colpitts, Clap oscillators. In RC oscillators, they use resistor and capacitors to generate low or audio frequency signals. They are known as audio frequency oscillators or AF oscillators. For example, phase shift and Wien bridge oscillators. Crystal oscillators use quartz crystals to generate highly stabilized output signal with frequencies up to 10 MHz. For example, piezo oscillator. Negative resistance oscillator use negative resistance characteristic of the device such as tunnel device. For example, tuned diode oscillator. There are two types of sinusoidal oscillations, damped oscillation and undamped oscillation. In a damped oscillation, the amplitude goes on decreasing with time. But in undamped oscillation, the amplitude remains constant with time. The essential part of an oscillator is the oscillatory circuit. A circuit which produces electrical oscillation of any desired frequency is known as oscillatory circuit or tank circuit. A simple oscillatory circuit consists of capacitor and inductor in parallel. Suppose the capacitor charged from a DC device with a polarity like this. The upper plate of capacitor has deficit of electrons and lower plate has excess of electrons. Therefore, there is voltage across the capacitor and the capacitor has electrostatic energy. When the switch S is closed, the capacitor will discharge through the inductor in this direction. The current flow sets up magnetic field around the coil. Due to inductive effect, the current builds up slowly towards maximum value. The circuit current will be maximum when the capacitor is fully discharged. At that instant, electrostatic energy is zero, but because electron motion is great, the magnetic field energy around the coil is maximum. Thus, the electrostatic energy across the capacitor is completely converted into magnetic field around the coil. Once the capacitor is discharged, the magnetic field will begin to collapse and produce a counter EMF. According to Lenz's law, the counter EMF will keep current flowing in the same direction. The result is that capacitor is now charged in opposite polarity, making upper plate negative and lower plate positive. After the collapsing of the field, now again the capacitor discharges through the coil in this direction and magnetic field arises around the coil and the magnetic field becomes maximum when the capacitor discharges fully. The sequence of charge and discharge results in alternating motion of electrons or an oscillating current. The energy is alternately stored in electric field of the capacitor and the magnetic field of the inductance coil. The interchange of energy between L and C repeated over and again, resulting in producing of oscillation. The frequency of oscillation is given by F is equal to 1 by 2 pi root LC. In practical tank circuit, there are resistive and radiation losses in the coil and dielectric losses in the capacitor. During each cycle, a small part of original energy is used to overcome these losses. Thus, the amplitude of oscillation is decreasing. In order to make the oscillation undamped, the amount of energy supplied should be enough to meet the losses in the tank circuit and the AC energy removed from the circuit by the load. The applied energy should have the same frequency as that of the oscillation in the tank circuit. The applied energy should be in phase with the oscillations set up in the tank circuit. A practical oscillator consists of tank circuit, amplifier and feedback network. Positive feedback amplifier. An amplifier with the proper positive feedback can can act as an oscillator. The amplifier amplifies the input signal Vi into A times Vi. A portion of the output is fed back to the input by a feedback factor beta. Therefore, Vf is equal to beta times A into Vi. If Vi is equal to Vf, we can have a faithful oscillation. For that, beta A equals 1. Beta is known as loop gain. Barkhausen criterions are set of conditions for sustained oscillations. The loop gain is equal to unity in absolute magnitude, that is modulus beta A equal to 1. The phase shift around the loop is 0 or an integer multiple of 2 pi, that is phase shift to beta A is equal to 2 pi n, where n is 0, 1, 2, etc. Voltage gain of positive feedback amplifier is A by 1 minus beta A. If beta A is equal to 1, AF tends to infinity. It means once the circuit receives the input trigger, it would become an oscillator generating oscillation with no external signal source. There are different types of transistor oscillators exist. Tuned collector oscillator. In tuned collector oscillator, the tank circuit consists of a transformer and a capacitor connected in the collector of the transistor. When the switch S is closed, the collector current starts and the capacitor charged to maximum and then discharges through the coil L1. This makes an oscillation of frequency F is equal to 1 by 2 pi root L1 C1. The oscillation induces some voltage in coil L2 by mutual induction. The frequency of voltage in coil L2 is same as that of L1, but the magnitude depends on coupling between L1 and L2 and the number of turns in L2. The voltage across L2 applies in the base emitter of the transistor and reaches the collector in the amplified form. The transformer gives a phase shift of 180 degree and an additional phase shift of 180 degree is provided by the transistor in CE mode. Thus, a total phase shift of 360 degree or 0 degree is occurs. As a result, the energy fed back to the tank circuit is in phase with the generated oscillations. Tuned collector oscillators are widely used as local oscillators in radio receivers.